Welcome to part 2 of chapter 6. We'll explore key mechanical principles and concepts that govern human movement. These ideas help us understand how and why the body moves the way it does and how we can apply this knowledge to improve performance, prevent injury, and advance technology in sport and rehabilitation. So let's begin with stability. There are a few basic principles that help us maintain it. Number one, the lowering the center of gravity increases stability, much like what you see here in this picture with this lady performing Tai Chi. By lowering that center of gravity, it's increasing her stability. Also, the closer the center of gravity to the center of the base of support, the more stable your body becomes. And so lowering your center of gravity towards your feet is going, in this particular instance, going to increase the stability of the body. And the wider the base of support, the greater stability. So the wider the feet are, the more stable they are. So she's in a good stance, and you'll notice that there are a few that are doing well with the wide stance and the lowering of center of gravity. There's a few that probably need to take their feet out a little bit wider and lower that center of gravity just a little bit more. Next, we look at the concepts of motion, which is best understood through Newton's 3 laws of motion, the fundamental principles of biomechanics. The first law, the law of inertia, tells us that an object at rest will stay at rest, and an object in motion will stay in motion unless they're acted upon by an external force. Now, in biomechanics, this explains why a soccer ball won't move until it's kicked, and why it won't stop rolling unless friction or another force, like a player or a wall, stops it. In athletics, this highlights the importance of generating enough force to overcome inertia and initiate movement, especially from a static position like sprinting blocks or a vertical jump. Now, the second law, the law of acceleration, this law states that the acceleration of an object depends on the force applied and the mass of the object. In formula terms, as force equals mass times acceleration. For example, if two athletes apply the same force, the one with less body mass will accelerate faster. In strength and conditioning, we train athletes to produce more force in less time, which are critical for explosive actions like a basketball dunk or a football tackle. Now, the third law, law of action and reaction. Every action has an equal and opposite reaction. In sport, this means that when a sprinter pushes down and back against the ground pushes up and forward, allowing the athlete to propel forward. This principle also applies in swimming, rowing, and even jumping. The more forcefully you push against a surface, the greater the return you receive, assuming technique and angle of application are correct. Now, understanding these 3 laws is crucial for coaches, trainers, and therapists. They help explain why technique matters and how to train for speed and power, how to improve performance while reducing the risk of injury. Let's dive a little deeper into the 2 primary types of motion we see in biomechanics. Linear motion. This is a movement that occurs in a straight line from one point to another. Think about the sprinter here, running down the track, or a hockey puck sliding across the ice, or a swimmer gliding forward through water. In each case, the object or body travels in a straight path with all parts moving in the same direction at the same speed. Now, rotary motion or angular motion is a type of a motion that occurs when an object or body segment moves around a central axis or pivot point, much like what you see here in this picture. Examples include a gymnast swinging on the bars, or a baseball player rotating their torso during a swing, or like you see here with track, he's swinging that ball around, and the flexion of the elbow joint during a bicep curl. The body part rotates around a joint, which is its axis of rotation. So in the case of a bicep curl, your elbow is the axis of rotation. Now, here's a key biomechanical principle. For any motion, either linear or rotary, to occur, the body must first be moved out of equilibrium. Now, equilibrium is a state where all forces acting on the body are balanced and there is no movement. To create motion, something has to change. Forces need to become unbalanced. A force must act on the body to disrupt this balance and generate movement. For instance, when a football player explodes off the line at the snap, they are pushing off the ground to break their equilibrium. A diver leaving the platform uses force to disrupt balance and create controlled motion through the air. Even walking involves a constant shifting of equilibrium as the body alternates between single and double leg support. Additionally, force is required not just to start motion, but also to stop it, slow it down, change its direction, or alter its speed. This highlights the importance of muscular strength and control in athletic performance and injury prevention. Understanding these types of motion and how they relate to equilibrium and force is foundational in fields like physical therapy, athletic training, and sports. Now, levers are a simple mechanical system that's used in movement. They have three parts. The fulcrum, is the axis of rotation. We talked about the elbow just a moment ago. It could be that's the fulcrum and a bicep curl. And so it's that axis of rotation. You have the force arm, which is the distance from the fulcrum to the force. And then you have the resistance arm, which is the distance from the fulcrum to the weight. You can see here in the picture, the load is the weight and the resistance arm is to the effort. So it's that pressure that's being put down by that finger. The levers help the body produce movement more efficiently. There are three different classes of levers. The first class is where the fulcrum is in the middle like a seesaw. The second class resistance is between the fulcrum and the force, much like a wheelbarrow. And the third class is a force between the fulcrum and the resistance, which is most common in the human body, like the biceps curl. Force is produced by muscle action. Stronger muscles generate more force, which is why we do weight training. When applying force, it's most effective when aligned with the intended direction of movement. Now, to absorb force safely, such as landing from a jump, we reduce impact gradually and over a large area. It's really important that we're training our athletes with box jumps to help to teach them how to land properly and safely, but also teaching them to land softly. This helps to engage those muscle groups to help and absorb the force safely. Force production and absorption are vital in sports like gymnastics and football and even running. Now, modern biomechanics uses a variety of instruments for analysis, including computers, motion capture systems, and high-speed imaging. Tools like EMG, where we're looking at how much force a muscle is generating, electrogoniometry, and force plates to collect precise data. And here you see in the picture, she's doing a leg press and the force plate is on the wall. These tools help us break down movement for performance improvement or injury prevention. Other instruments we use that play a vital role in collecting data to analyze and improve human movement are anthropometry. This refers to the measurement of the human body, its size, its shape, and composition. It's often used to tailor equipment, design ergonomic friendly tools, or analyze how body proportions affect movement patterns. For example, limb length can influence stride mechanics. Timing devices or chronoscopes are used to measure how long a movement or specific phase of a motion takes, down to the millisecond. They're essential in sprinting, reaction time drills, and other time-sensitive sports skills. Electrogoniometry. This tool measures joint angles as they change during movement. For instance, it can track how far the knee bends during a jump or how the elbow extends during a throw. It's especially useful for identifying abnormal movement patterns or comparing left and right limb function. Electromyography, or EMG, measures the electrical activity of muscles. It tells us when a muscle is activated, how intensely it contracts, and in what sequence muscles fire. This is key in both performance optimization and injury prevention or rehab planning. And dynamography, sorry, I've had trouble saying that. This measures forces such as ground reaction forces during running or jumping. Force plates are a common dynamographic tool that can assess balance, strength, and the symmetry of movement between limbs. And telemetry. These are systems that allow for wireless transmission of biomechanical and physiological data in real time. This is particularly useful for monitoring athletes during actual gameplay or practice without restricting movement with wires or lab setups. And wind tunnels. While often associated with auto or aerospace engineering, wind tunnels are also used to study the aerodynamic properties of athletes and equipment. For example, cyclists and speed skaters can refine body positioning to reduce drag and increase efficiency. So each of these instruments contributes to a deeper understanding of how the body moves, allowing professionals to improve performance and prevent injury and customize training. Now, in utilizing those instruments, analysis can be either quantitative, where we're using instruments and measurements, or qualitative, where we're relying on trained visual observation. Both are useful. Quantitative analysis gives us precision, it gives us numbers, while qualitative gives us insights into patterns and techniques. So it's good to use them together. To perform good qualitative analysis, it's important to choose the right vantage point. But I would expand upon that and say that you want to look at different vantage points, so other vantage points. It's just like with camera analysis. You want to look from different points because you see things differently. You also want to watch multiple times and use a whole method that looks at the entire movement, then at individual elements, and then the full movement again. And use a checklist and observe both the performer and any equipment involved. If we look ahead, biomechanics will continue to evolve. We'll see more collaboration across disciplines and greater use of data for customized solutions, as well as enhanced support for people of all abilities through technology and movement science. It's important to also address misconceptions in biomechanics, such as the idea that athleticism is tied to a race. We must also recognize the role that biomechanics can play in creating inclusive opportunities for those with disabilities, amputations, or spinal injuries. The field has the power to make sport and movement accessible to all. Now, some current trends include, of course, smart apps and wearables for real-time feedback. That's more of the quantitative data we just talked about. And 3D printing for personalizing equipment. Virtual reality is being utilized for movement analysis and training. And biomechanists are now essential members of multidisciplinary sports science teams, helping people of all ages and abilities move better and safer. So as we wrap up today's presentation, let's just revisit some of the key mechanical principles that influence human movement. First, we discussed stability, that lowering your center of gravity and widening your base enhances your ability to stay balanced and in control. Then we look at motion, which follows the Newton's laws, whether it's maintaining inertia, accelerating with force, or reacting to contact. These laws govern how we move. And leverage plays a vital role too. The body uses first, second, and third class levers to perform different types of movement efficiently. We also emphasize force, how it's produced by muscle action, how it must be applied in the direction of movement, and how absorbing it correctly can prevent injury. To better understand these movements, we use advanced tools from EMG to motion capture to analyze and improve our performance. In terms of analysis, both quantitative data and qualitative observation are valuable in identifying movement patterns and opportunities for improvement. And as we look forward, we explored exciting trends like wearable tech and virtual reality and 3D printed gear, which promises greater customization and inclusivity in movement science. And that is all that I have for you today. I look forward to talking with you again. Have a great day.